So welcome everyone. Hopefully you can all hear me. I'm not on the main screen right now, so if you can, I'm going to have to find out in a little bit. Welcome to our opening of our Spaceport lecture series. We're really excited to have tonight's speaker, and I'll introduce Evelyn in a second. I just want to let you know how we're doing this. Some of you may have been there in April or May. I can't remember now when it was, so long ago. When we did this online approach. What we'd like, there's not the ability to, or at least we're not allowing it to interrupt with questions. You can maybe put your hand up or put something in the chat, and then if I see it, if I feel I can interrupt Evelyn in their flow, I can ask that question. But what I'd like you to do, if possible, is use the Q&A section. If you're somewhere on your screen, if you're on a regular laptop, it should be at the bottom of your screen. There's a Q&A option. And if you put your questions in there, I will try at the end of the presentation part, I will go through them in some kind of order. I'll try and do them first come, first serve, but there may be multiple topic or maybe multiple questions in the same topic. So I reserve the right to switch out. So let me just introduce the session a little bit. So my name is David Alexander. I'm the director of the Space Institute at Rice University. As part of our support from the Houston Spaceport, we've been running these lectures for several years now. We've had some great speakers. And we have finally we have a lineup, and I haven't posted it yet, but I'll post it a little bit later, maybe tonight or tomorrow. We have four speakers this season, September. I guess this is the 17th tonight. We have a speaker talking about human health and mitigating health problems in space, October 8th, I believe. Don't quote me on these dates until you see the announcement. November 5th, we have an astronaut/doctor. Serena Onan Chancellor, who will be telling us about her missions and some of the stuff that she's been doing, again with astronaut health. And then we have an interesting lady from Arizona who will be talking about the space policy aspects of colonization and what she thinks about that. She's got some very interesting views on what it means as we maybe perhaps move out into settling Mars and the moon and so on. So I'm really excited about our four speakers, and particularly excited about tonight's because, as usual, I was badly prepared and I had to put out an emergency call. And I've been getting to know a little bit more about Evelyn and her work in the last year or so, and her connections with Clear Lake and with the Houston Spaceport as well. So I'm really excited to have someone of the caliber of Evelyn giving in the opening talk for the session. So let me, as long as everyone understands the rules, Q&A for questions. If there's something that you think really needs pressing and relevant to the time, put it in the chat, and then I'll try and catch it and interrupt if I can. So tonight's speaker is Evelyn Miralles, and she is currently the Associate Vice President for Strategic Information Initiatives and Technology at the University of Houston Clear Lake, and she's a former NASA Johnson Space Center Chief Principal Engineer for the Virtual Reality Lab, and that's been used for many different things, including astronaut training. And so she's part of, I'm sorry, I don't understand. I don't know what CACI stands for, but CACI International at the astronaut training facility. She's a pioneer visionary who served as Chief Principal Engineer at Johnson Space Center, and her work in virtual reality has been integral to the enhancement of human spaceflight exploration. We'll hear a lot more about that tonight. Training the astronauts, the US astronauts in particular, to basically do some of the most dangerous things that they get to do, which is EVAs, and working with them to understand what that's going to be like in a sense, even though they have to go out and experience it for themselves. Evelyn retired from NASA just last year, but Clear Lake is stepping up in their role to be more engaged with these kind of activities and engaged with NASA and the space community. So she has stepped into that role to help with that in this position, as I mentioned, the Associate Vice President. She graduated from Clear Lake with a Bachelor of Arts in Computer Information, and got an MBA just back in 2012. She's originally from Venezuela, and got a Bachelor of Science in Computer Graphics from Lamar University. That's where she discovered her current passion that has led her to the contributions that she's made today. So I will assume you're all clapping as you join me in welcoming tonight's speaker, Evelyn Miralles. Thank you. Evelyn, it's all yours.
Thank you, David, and thank you for the invitation to participate in this wonderful series. Let me just move my monitor here. So yeah, I want to, thank you and thank for all the people attending tonight to listen to this presentation about how virtual reality technology is actually transforming human space exploration. Even though we're going to go through a little bit of historical pointers that are important in order to understand really how far this application has gone. So thank you, everybody, and thank you, David. So we're ready to start. Let me just check my time. Again, I don't need to introduce myself. That was done. First, I'm going to start to address basically about the description in understanding what virtual reality means. And this is because it's important to understand the difference between this reality and the augmented reality and the mixed reality that we hear. And many people uses everything together, and they're different, and their applications of these technologies are different. So virtual reality is really the perception of being physically present in a non-physical, in a world that is digital. And in comparison to augmented reality, when you use augmentation, you are present in your real world and you augment that world with synthetic elements. So that's the biggest difference. So if we go back to history, which is very important to go back when we started to develop the virtual reality technology, we need to definitely take a look at what the helmets, the evolution of the helmets, because the helmets, which are the visual part, the optics of these systems, is the most important. And in the development, actually, if you look back in history, right, we started using computer science as a science was developed about mid-50s, and it continued to evolve. Systems were coming up in the 60s, 70s, personal computing in the 80s. So we're not that far away from all this revolution and evolution of personal computing. So in the 60s and 80s is when the first time that it was really taken to develop optics for the military. NASA Ames had actually developed a lab, had a lab that was constructing helmets to use for autonomous robotics, to actually do robotics from far away to other planets. And they were trying to develop the technology in order to obtain that target to use for robotics. But again, as you can see here in this picture, helmets have evolved. And not only, it's not so much the physical, but the internal aspect of it and what's happening internally of these helmets. As you see it right here in the screen, a lot has changed in how the processing and the optics have evolved, which is tremendous. So do you think the VR technology has evolved quickly? Well, it has not. And the reason, and it's very simple, is because we didn't have the computing power. The hardware was a lot more expensive back then. We're talking, like I say, in the 80s and 90s, we had computers that in servers that were millions of dollars, hundreds of dollars. A helmet back then was $100K per helmet. So, and at the same time, through time though, the hardware has become more cost effective, and the development though, the software side has become more expensive because Everything is getting more complex. Now, I want you to all put this all in perspective, because as I'm going through these kind of historical pointers, you're gonna really see the impact and the effect and the transformation that virtual reality technology had to human space flight and to human space exploration. So here you see actually, you know, photographs that I took in 2 different scenarios, training astronauts for spacewalks. And there are 2 different helmets right there. I'll show you in a minute a little bit more about the hardware. So here is another picture. And again, I bring this because it is important to know that even until this point, and we're talking about late 80s, early 90s, there wasn't any really comprehensive virtual reality system for space exploration. 1992 was actually the first time, and you see that picture on the top corner that you can see here, where that was the first time that we immersed an astronaut using a helmet in that scenario. And the scenario was precisely to do an EVA in a spacewalk. And if you can continually see all the different transformation that the technology had, we got until today. Here is the latest astronaut using the same technology. So many things have changed internally, and that's probably some of the things that we're gonna talk about. But the technology has really been extremely impactful for human exploration again. And here I'm gonna show you in a little more detail of what the changes in the optics, what that is the main component really of the VR system. And I mean, you can read here the resolution in the 1990s. I mean, the resolution was CRTs, you know, something very difficult actually to use for an astronaut. I mean, the machines were slow, and the resolution of the images were very low too, latency. So there was a lot of constraints, but there was one thing that was important in common, is that we immersed the astronaut in that environment, in an environment that cannot be replicated any other way. This is a little bit of, again, historical pointers on the head-mounted displays. Now, here is the first use of VR for space training, which was done in 1993 at NASA Johnson Space Center for the Hubble servicing mission. And that was the first time that we, of course, as I mentioned before, where we truly integrated the virtuality with the training. And this was very important because the astronauts kind of help us to do that. Some were veteran astronauts that were already have flown before, and they gave us the pointers of what we needed to be looking at in order to develop the system and the components, and graphically what they were going to look, what they're looking at. It's important to mention that back then, you know, because the speed was not good enough for having a flow immersion, we gave that up for the immersiveness, because again, it was very difficult to replicate. And so what happened is that, and this is the biggest moment for virtual reality, the biggest need for VR R&D, research and development, was to really support spacewalk training. And that was brought because of the need for human immersion. And this is something that it was really impactful. It never impacted me as much until many years after, because we were very immersed in developing the technology. And it took so much development integration. If you think of every time there was a new helmet or there was a new type of logic that we could implement to the system, we will integrate it, and then we have to test it and then prove it through the training. So it took many years, And it was very impactful after seeing that this was truly the reality, why the VR was so important, and it was making such a critical addition to the training. So the VR systems, in you know, all of the VR systems have these are the main components that any VR system have. And I'm not gonna go into the details in the individual, but we have a graphic engine, we have IO devices, which are helmets, pointers, anything that we can point. And nowadays these are wireless, and these are sometimes optical. And there is many ways that the IOs are being implemented nowadays. You also have what is the data in the content, which is extremely important, right? So all these pieces of 3D models, modeling, and all this content goes in here. And then you also have the simulation. And simulation is basically all the mathematical function that you can add to this system to make it do whatever you want. And one example of that is for robotics, in robotics operation. We will have a simulation run on the side of the system that will tell, you know, when we move a component, that the articulation is precisely as it should be. So it's basically mathematical, procedure, those mathematical procedures that will tell how each component within that system works. So these are very important for the system, right? So VR provided, as I said before, VR provided this very unique immersive environment that we couldn't replicate any other way. And the astronauts, this was probably very, very interesting, because they felt that that by using this immersion, they were going to have a better understanding when they went outside of a vehicle to do a spacewalk. And remember, we were the main training scenarios that we were covering was spacewalks, which is EVAs, extravehicular activities, robotic operations, and also some type of mass handling. And that mass handling was actually done also with a robot that was tied up to the VR system. So you could sense and you could feel moving something in a space as you were immersing the environment. So I just mentioned that, but that's a very complex system that has all these parts necessary in order to make that happen. And the astronauts many times will come back, and from their missions, which was the most important, and it will give us the input and tell us what worked and what didn't, or what was the most realistic part of the whole scenario, and or what needed to be improved. And this is important too, because I talk to a lot of people about creating the systems, and it's good to talk to your clients and what they're needing, and constantly having a talk and conversation back and forth. And for us, it was the astronauts, and for this purpose. So an important point, right, to be made when we're talking about human exploration and how we have done training throughout so many years, we have used the pool, right? And the pool is something well known for many, many years. And it provides a really unique place, right, where you can be floating, although you have the water, so you're dragging that, so it's not really zero G, or you cannot really replicate zero G on Earth, but it gets down to the closest, where you can test the suit, the spacesuit, communication. So there is a lot of things that you can do and you can train for in the water, but still, they don't see the whole space. They don't see the whole space station. The astronauts don't have that view. And this is where VR is so important. The other way in which we were actually training astronauts, even in conjunction with the pool, was mock-ups, like in a mechanical. which is very difficult to configure, expensive. So it has a lot of constraints, but NASA also tested these mock-ups in order to do some of the training. And we very soon, as the graphics technology became better, we realized that computer graphics and having all these components graphically, synthetically represented will give us the most agility in configuring these scenarios. And it did. So here is a representation of the space station. And basically, this is the base of VR. From this, you could use a VR helmet and be literally immersed in that very complex environment that you see in front of you. That is that beautiful representation of the space station with all the components digitally, graphically. So how is VR transforming human space exploration? Well, it has transformed literally how we train for human space exploration. And it has impacted the visualization. So we're talking about the immersiveness capabilities, spatial awareness. It has impacted processes. They integrated into design, testing, training, operations, and I'll go over that in a second. Reconfiguration, lowering the costs, content, and improve collaboration. So all this has, in all these areas, VR has had a tremendous impact for exploration. So if we look into visualization, I mean, and as I mentioned before, but this is very important, you know, the fact that they can see the whole space station and understand where the astronaut, the crew member is located. And if there are two working outside the vehicle, to understand where you are in reference to the space station was extremely important. So the visualization of that activity was is important, and it's something that VR provided, as you can see, immersively. The processes. So what happened now is that because of development of all these VR systems, and we can actually improve the processes. And as I said before, I mean, the processes into designing. So we can use VR for design purposes. You can measure things, you can position items in different places, color coded, whatever you want. And then after that, then you can go ahead and take that and test it. And then after testing, you go ahead and use that same scenario. So you're not changing, but all digital, and you're applying it into training. And then after training, you go ahead and say, okay, now we're ready to do operations with that same scenario with some modifications. And then you finalize with maintenance. So all these processes are definitely being improved in using the technology. And in one simple, you know, set and subset of that, that's all. So it's definitely has made an impact in this area. Also in reconfiguration. Throughout the time, and we spent total of probably over 6,000 hours training astronauts. The reconfiguration for every flight was important. We have to be ready for what was going to happen, the way that they were going to see it, even though if it was in the future. And the only way you can do that very quickly is synthetical through the graphical systems. And of course, again, the virtuality comes in the immersion. So you add that to augment that presence. But internally, the base of everything that is happening in a virtual reality system is the graphics. So we are able to configure all these scenarios very easily in these systems. The next is lowering the cost, like I said. Now, we went through, I can tell you from cost analysis in short, we were spending over millions of dollars, hundreds of thousands of dollars to probably 25, 30K. With the same system, you're doing basically the same, even better nowadays. So the cost and reduced cost of using now these VR systems are incredible. From the 90s to now, it's just amazing how the things that we can do and the power we can have in a very small area. You don't need that much too, which is another thing that VR brings, that you know, you can have it anywhere. The other is the content. So now virtuality, and like I mentioned in my first slide, with virtual reality, you're creating a synthetic world, and you're creating whatever you want, whatever you need it to be, whatever component you need it to be, from whatever essence. It could be photographic, it could be, and I'll talk about that a little bit later on. It could be something that you build from, like I said, 3D models, you know, already done, different formats. All this you can do, create, and make your scenario how you want it. So imagine, you know, building not only the space station like we did outside, but we can do it inside. We can do landers, we can do anything. So the content and the versatility of creating this digitally is, you know, incredible. And in here you see an astronaut actually using the VR for a system that was getting ready to go to space. This is the first VR, virtual reality system for refresh training on the space station, which I'm sure we will do more of this as we go into the moon and stay on another planet. That there is going to be the need for a lot of these systems. And then the last part would be the collaboration, like I mentioned before. Now with virtual reality systems, you know, we can collaborate. We can have different, people call it avatars. I don't call it avatars, I call it crew members. We can have these crew members in that same environment, working in collaboration. And we did that a lot because the crew members needed to collaborate when they were gonna do in a spacewalk, to see and to make sure that they understand their communication. When they talk about moving something to the left, to the right, up and down, what does that mean in a space? So virtual reality definitely provided this in a more easy way, and in a more agile way, where we can redo this scenario over and over. We can just click a couple of buttons and literally come back to the initialization of that activity, and they can rehearse it all over again. So definitely, this is an impact in this type of modalities in which, like you see here, you have two EVAs, two crew members going through their EVA procedure, and so it's definitely created an impact into their procedures and how they perceive that activity. So something that we learn through the time, obviously, is that although we were creating and we were developing all this technology, it really, the biggest component for virtual reality has been obviously the helmet. And throughout the years, as I showed you in the previous slide, you saw the evolution of the helmet. And it didn't happen until 2010 when Palmer, he was a young student in a community college, he created a commercial helmet, literally, the first Oculus. And until that point, we were literally building our own, kind of in prototype through NASA, within NASA. And that took a lot of time, because when you have a full VR system and you're trying to support every mission going to the space station, that took a lot of time. We were doing not only design, integration. So the helmet, although was the important component for immersion, we had to basically prototype it and basically modify it to our needs. But it didn't happen until 2010-12 when the commercial helmet came out. Like I said before, Palmer created this helmet and was sold and bought by Facebook. And at that point, it became commercial. And that was really, and became commercial about 2014, which is when Facebook bought it. And at that time, it was when the boom really of VR happened everywhere, because because many people now had access to this, and computer graphics, computer graphics, the computing and the video cards and the graphic engines were getting better, and is when people were able to really spend more time in development. So this was a really important breakthrough, and it's when really, when you use that VR for more development is when it gets to the maturity level, and that's when it happened during that time. And I just wanted to bring that because it's important as we develop the technology to confirm this in our timeline. I go back again to this system because now I'm gonna aim and talk a little bit about the graphic engines, which is important in a VR system. So we have worked throughout the years with many graphic engines and NASA for human space exploration. And we actually, when we started working on the in the 1990s with the Hubble Space Telescope servicing mission, we had to create our own graphics, which is called DOG, Dynamic Onboard Ubiquitous Graphics. And the reason is that there wasn't anything out there that will allow us to have the flexibility and the changes internally in the coding to actually do what we wanted to do. And we're talking from internal manipulation of data to externally into GUIs and at that level. So later on, and eventually Unity, Unreal came on board, and they definitely advanced their technology, and now it's used, all of them are used through NASA to develop the content for VR systems. So it has really improved exploration because of this enhancement. Now, this is a very important topic and part of VR, and I wanted to talk about this because I think many people lose the understanding of the applications of VR systems and what we're using it for, and we have to be very careful because first we have to understand about the human sensory systems and how VR plays into that, and how VR is developed for the specific use that you have. So first, we need to understand all our 7 senses, and obviously the biggest one for VR is sight. And I put it last because I want to make sure people understand that the sight and the vision is the dominant sensory system, and this is why VR has been so impactful. Because if you tell me, if we know that touch is the most, is the dominant, then we wouldn't do VR. But the visual is the most dominant. So it will dominate against all of the others. So this was very important to know that when you develop a system, you have to know what are the senses that you need to train the most, or that you need to be aware of, and then train and then develop your system towards that goal. So obviously the proprioception, which is the body position, is the other part that is used a lot in VR, and is the most also the secondary sensory system that is important for the systems for human spaceflight. So if we go back and we look at EVAs, right, extravehicular activities, well, again, the visuals was the most important component in sensory that we were trying to represent, and basically also the body positioning. It was important to be immersed in this environment to know where you're located against your other EVA person, or within the vehicle, or outside the vehicle. And then when we're in the water pool, if we go back to, to this kind of training, you really are paying more attention to the touch, right? The feel, floating. You're also very, very involved with your vestibular system, where you're located in relation to that work site in particular. But if that crew member, look around, he's gonna see divers. He's gonna see portions of machinery that is not going to be in space. So that's not a necessarily, you know, complete training. So what we discover, right, through the development of VR is that we can merge these two training very nicely. The virtual reality environment is going to give you the sight and the vision, the power of that, and the body positioning, and what is it, spatial awareness, like we say. And then the water pool gives you the touch and the vestibular more than anything. So when we merge these two together, that's when the power of training for an EVA really happens. And this is why VR has been so critical and transformative for human spaceflight. And it is, you know, very important to understand that. And as VR got better, then at NASA, we realized that the deficiencies of the pool work. Not for nothing bad, is that we started seeing, okay, hold on, we can replicate all this in VR, in graphic, in digital. So, you know, so it became the merging, and we started to really work more collaborative, actually, with the pool training. So what's happening now, right, as I mentioned before, is that, wow, now we have the ability with VR technology to replicate and build and design modules of any kind. I had so many photos, I thought, well, I think if I just give you one photo where I'll show you, you know what, you can build anything you want to, anything you need to. And the commercial industry is gonna have a blast doing this, because now you can build the modules, you can play with the lighting, you can play with colors, positioning of equipment, storage places. All these can be designed using VR. You can get immersed and you can see how it looks like. How many people can it be in the space? How many crew members can live together? How can you move around? I mean, there's so many incredible opportunities for designing. And then again, you always look at, you start with designing, you use VR, and then you take it through the process. Designing, you test, you train, you operate, you maintain. And it all can be all done now using virtual reality. So, and again, collaboration, you're gonna use that, and you can be literally anywhere in the world collaborating for this effect. So we did a study for example, in this scenario where we were looking into the inside of a crew module, the Orion. And if we place a machine, a mechanical exercise machine, where do we place it? How the astronauts were gonna be seated, all that can be done, manipulated very easily, and reconfigure all these pieces using VR. Also, NASA has been experimenting with offloads type of facilities, where instead of going underwater, we can offload a person and give it a sense of zero G. And if we do that, then we will have to use a helmet for immersion, for the visual part, which it will create a different type now of agility in terms of the different type of configuration we can have. And one of the ones that we were looking into with this system was to simulate walking on top of on the moon, right, on a planet. So this is another area where VR has made an impact because now with the helmet, with the wireless helmet, wireless computing. So we have the cloud, we can definitely propagate that data, all that data to the helmet, and we can see anything we want. So this is another area of impact. One important also area actually that where VR has been impactful for human spaceflight is outreaching, because the more people see what other people don't have access to, which in this case will be inside the space station, inside habitat, in the moon, or whatever we go to. People want to see that. And now with the VR systems, we can share that experience with anybody. And using photographic content like is here, and this is just an example, we can actually really represent and show to people the reality of what it is to live in the space station. I mean, to really see it, see real pictures, like it's not, this is not digital content, this is all really photographics. So you see the inside of the space station here replicated using photographic type of technology. This was done, I think it was done last year, very recently, where the whole space station was photographed, and now is available to display on helmets. So obviously, this can be done in other places, in any place you want. So the technology is definitely here, and it's getting better because it takes a rig and empowering with the cameras to do that. And I'm sure this technology is gonna continue to improve to develop photographic content. The other very, very important area where VR is continuing and is transforming really is in the cognitive and brain function, and basically the psychology and human factors, and also the opportunity to create more personalized medicine for who needs it in a space. So we can really have the astronauts, individual astronauts can have their own sets of scenarios depending what they need to do. If it's, so among the most important really factors in crew health and human performance is sustaining the mental health. So it has been a study already that obviously long duration space mission has an impact in the psychology, and VR is having actually the effect, is being proven on Earth to have effects to mitigate different mental problems that rises. Could be to control pain or mitigate stresses. And this is gonna happen when we go, to the moon even. So the use of VR is essential, is critical. And that's why it's continued to make an impact to address all these problems that are gonna be happening. So the upkeeping with the mental health and the opportunity to have a more personalized medicine attached to in a specific, to the crew members will be extremely important as we go beyond LEO. So as you can see here, I think Luca Parmigiano was testing a set of semiconductor performance. It's called gravitational references for semimotor performance, where he's actually testing the central nerve systems when he's grabbing that little handle that he has there, and he's getting all that data. So all that is done and visualized through the helmet. So very impactful. The next slide is really kind of telling you again a little bit about how VR is going to be helping, and it's continuing to make an impact in maintaining brain and the vestibular fitness actually during long duration flights, and not only during the long duration flight for a human, but also after. So when they come back to Earth from space, they're using now VR to actually mitigate some of the problems that astronauts suffer with having the gravity, right? Experiencing gravity again. And that goal goes to the vestibular system, aggravation. So I think that VR has really has some major impacts that not only has done is doing and we will continue to do. And the transformation in human spaceflight from this technology has been incredible. VR provides a control and repeatable scenario for situational awareness. It provides makes it possible really to explore places that we cannot do any other way, have access to resources that might be prohibited or expensive. So now, you know, people from all sorts of life can actually be part of the developer, be part of the developer team, provide now innovative ways to visualize and manipulate the data, because even for that it's good to visualize data immersively, has a tremendous impact. So there is no doubt that VR has had its impact. And my last slide here, which is kind of meaningful to me, because I always, as I was working in this technology for many years, I realized that the biggest impact that VR is going to have is when we go down to the moon, and hopefully that happens sooner than later. And I have no doubt that we're going to be able to follow an astronaut real time uh, from our homes with a VR helmet. So as they're stepping down the moon, with the cameras and the powerful cameras they're going to have, we're going to be able to stream that data and see it real time as we actually walk on the moon again. And that's going to have a tremendous impact in human exploration for many generations to come, because it will be for the first time that we're actually immersed with an astronaut fully. And with that, that will conclude my webinar today. And as you can see, you know, obviously this has been a passion of mine for so many years. So I want to thank you for the opportunity to share some of this information. My Q&A.
Thank you, Evelyn. I'm going to, since I haven't the one with the microphone, I'm going to applaud for everyone. but thanks a lot. And I know people are maybe warming up to the system. So if you've got questions, please put them in the Q&A. And I may, if you put your name on it, I can either attach your name to the question, and I can maybe even bring up and allow you to ask it verbally rather than just written. So while we're waiting for people to think of their questions, okay, I have one, but and we always defer to our audience. So
do you want me to share, or should I leave it here? Okay.
You can, yeah, no, you can still, no, you can still share the screen. I can read it out, and let me give Deborah the opportunity to ask it herself. Deborah, if you're willing, you can say no, and then I'll switch and I'll just read out your question, but I'm allowing you to talk right now.
Okay, well, thank you very much.
There
I've
we
done
go.
virtual reality once at an exhibit here in Houston. And what I was wondering is, how do the eyes change focus when there's simulated distance? Do the eyes focus in the distance, or are you able to actually give astronauts some relief from focusing close all the time? Or I guess they could look out windows, but how do the eyes focus in virtual reality?
Well, so remember that there is a limit for that, right? You cannot refocus on that. So it is whatever it is. You cannot change that basically. So so that's something that is difficult to do. I mean, it's difficult to do. It's basically not possible to do, to release that. So that's why the systems, you cannot use it for too long, because it strains your vision a little bit. And we have found that out through the years, right? You know, you usually, we will go through a training for 30, 40 minutes, and then the eyes will become a little bit, you know, tired. So that focus cannot be changed.
Okay, and we have a question from Leanne, who's one of our professional master's students. Leanne, I'm going to give you the permission to talk, and so you can ask your question of Evelyn now.
I wanted to know how VR can help with mental health. Do you have like any specific examples that you could share about that?
Say that again. The mental health.
I wanted to know how VR could help with mental health. Since you mentioned mental health, do you have any specific examples that you could share?
Well, okay. So there are several examples I can think of. As I mentioned before, for example, for controlling pain, for decreasing stress, sometimes for changing habits. There has been many research done about the use of VR for those scenarios, and it has proven that it works. Now, the content, the development of the content for those specific scenarios, that is something that it will depend who is doing it, and that's why it's so broad that you have to really look into what you're looking for more specifically. So the VR has many applications because I mean, you imagine that you can actually create any scenario to modify how people think of something. So let's say even if you're in a scenario where you're switching your limbs, your hands and feet are reversed, and you visually see that, and you imagine you're capturing that. So see, what I'm saying with this is that whatever the problem you're looking to solve, the mental problem, you just need to make sure that you create that scenario for that, and that is impactful, and that's where the complexity comes. But it's used for relieving pain, for like I say, stresses, for imagine we're traveling to Mars, and you're getting stressed, right? And you're getting, we get detached from the other crew members. Well, with VR, we can play some games or things in situations where you can mentally get you back on track. So things like that. So, there are many that you can probably search and see what people are doing also.
So I have a question from an anonymous attendee, so I can't give them the voice because I don't know who they are because they're anonymous. But the question is, how do you think neural stimulation technologies like Neuralink will play a role in future virtual reality training? So neural stimulation technologies. I'm not familiar with Neuralink, but the one referenced is called Neuralink.
Yeah, and that might be, it has to do sometimes with the nerves, right, in your head. I mean, having some stimulant to produce some type of, because one thing with VR happens with the vestibular system, right? That with VR, you can have the sense that you're moving when in physicality you're not. So you're having sometimes a misplacement of your vestibular system, and for that, there have been some sensors that are being used, electromagnetic kind of pulses that you can place in your head, and it gives you the sense that you're actually physically moving, so that you don't feel dizzy. Because if you're not physically moving, but visually you're moving, you're gonna get dizzy. So there are some stimulus that are being used. I don't know how effective truly that is up to today, but I remember testing that with some at some capacity. And actually, I do have a story. We did test some time with haptic sensors, giving it the sense that you're touching something, and kind of having buzzers and sensors, and that didn't work too well in VR for what we were testing it for. But yeah, that's all definitely happening, and it's to mitigate that vestibular imbalance that happens within VR systems.
So I think we're going to have a question on haptics again in a second, but before that, Kathy Dupree, I'm unmuting you, Kathy. So if you'd like to ask your question, please go ahead. You may be muted on your end, Kathy. Are you there? okay, given that that doesn't seem to be working, let me ask you Kathy's question, Evelyn. With COVID-19, how will it affect the use or precautions for use of VR training? Has it impacted VR training for space training? So how are things, how, I guess one way of parsing that is how is NASA continuing with their training in the COVID-19 situation if you can't put all these people in the lab or?
Right. Well, they're still training in what they do. Obviously, they do it in with less people around, right, because of COVID-19. But if you look back to the presentation and what I was talking about, that you don't need that many people anymore. It's all virtually. So the number of people that you need to actually maintain this type of systems is not that much. You can actually literally do many of the maintenance from away from the place or telecompute. So I don't think it has done maybe an impact in terms of the scheduling, you know, who's coming and who not, but in terms of the virtual reality and the technology, it's actually, I don't think it has had any impact. It's just getting more flexible and maybe allowing for more people to develop from away from the office, which is actually great because you have a lot more, the more people that you have developing, the better, or they understand how to develop, the better. And the more you build that, that's why it's so important to continue the education into how to do, you know, and how to implement these systems is important. And IO and everything, yeah.
Well, thank you. So I'm going to go back to next in line is Leanne. Leanne, I'm going to let you talk now so you can ask your question.
So I wanted to know, I know you previously mentioned that people are currently using haptics in their virtual reality trainings. How much of current virtual reality trainings incorporate haptic feedback, and also what kinds of haptics are used to artificially stimulate certain responses?
Well, I don't remember exactly the type that we used. This was many, many years ago. I remember we were actually doing a simulation of a EVA on an asteroid, if you know, incredibly. Nowadays, they probably will have more effective type of haptics sensors that maybe you can use that are wireless, that can be easily integrated with the system, because remember, you got to read all the pulses and see what you're reading and how much force you're giving it, and, you know, et cetera, et cetera. But there might be some better ones nowadays. I don't know exactly, you know, the availability for that. But one thing that is important is when that's integrated into the system, how is it playing with the activity that you're doing, with the movement, with whatever, and that's the integration part that I will be more concerned about. If you're looking to haptics to, for example, touch a panel, you know, touch a panel with your hands, and that has been done in VR and has been trying to be recreated, and so it's not easy, you know, to being able to touch something and feel it, and you know, and not have problems with your sensors or you know, so that I haven't seen anything so effective that could simulate the real world. And this is also where augmented reality is coming into place, because now, let's say that you wanted to create a panel, you know, doing some manipulation, and you can actually, you know, have that panel physically and then augment the different labels and information that you need for that. So see, I think depending on the application, you might need a VR, or you might need AR if it's a lot of touching or things. So I will have to look at the specific case. But for the cases that we had and we tried it for, it wasn't good. It wasn't positive, the haptic information that we were getting.
Yeah, Leanne just is working in the haptics lab at Rice, so she's very interested in the whole haptic aspect
Yeah.
of everything. So that's good. So time for a couple more questions. Kirsten, I'm going to switch your mic on, so you're free to ask your question. This is Kirsten Seebach.
Hey, thanks. I was just going to ask, it seems like the market for home VR systems has really gone up and down, and it just hasn't really taken off. And I was wondering if you think that's attributed to something like not comfortable enough or maybe not cheap enough hardware. But what do you think will become common in homes in terms of VR technology?
That's an interesting question because, you know, people make so many projections. VR system, okay, let me go back because I will give you a reference. When we were training astronauts, the veteran astronauts, they didn't want to use VR anymore. Once they knew what that action was, what they saw the first time and how they did it in VR, they didn't want to use it anymore, or not as much. Because once you see that scenario and you experience it, that's it, that's all you need. Now, VR for home has a different, you know, kind of feel, and is that being immersed, fully immersed in the environment, is not for everybody, and it's not. It's difficult. It's not easy to develop fully. It's like being in a game all the time, being in an artificial game. And if you think right now we're in COVID-19, this pandemic, we're all virtually talking all the time, and many of us might not like it. You know, we wanted to go out there in the real world. So the same happens with VR. I mean, you're inside constantly in an artificial environment. So unless you have a mission and a purpose to do, like when you're doing a game, right? Or you have a task for human space exploration, then it's good to be in it. But other than that, people don't feel like, well, am I gonna be in VR for experiences? I'd rather go outside and do it. So see, those are the you know, questions that many people ask in terms of the technology for other purposes than just a specific task. So, and that's the way that I will define it. Unless you have a specific task, just using VR for the fun of it, many people might not find it fun. Actually, they are probably not. And that's why that up and down in that technology. And it's also important, and this is probably will be my next topic, is into augmented reality and mixed realities, which is gonna have a truly impact in the way we interact with anything in the space, because it's actually, it allows to see our real environment and allows to basically make it better and augmented. So, and that's what is called for me, information immersion, because you're gonna immerse with the information in the real world. So that's why I don't see VR, the impact that people talk about is limited to the mission, whatever that is, in a space, medicine, whatever. But other than that, I do have questions in why people use it.
So I think I'm going to take the opportunity to ask a question, and I'll leave it open for anybody else who wants to come in. Oh, let me ask my question so that I'm not the one asking the last question, because Dawn is asking a question here, but let me ask mine, and then we'll get to Dawn. So you talked about obviously the hardware. You're mostly focused on the hardware and how important the helmet is, but clearly a lot of work has gone into the creation of that environment. So how much of that is done in-house? How much of it is done, you know, by, you know, I know everything's contractors, but and when, as we think about Mars and the Moon, how does that get better? How do you make the world seem more realistic? Is it the photographic aspects, or how is that? How do you envisage the software part developing?
Well, nowadays the rendering of the graphic scenarios are getting incredible. They're more powerful than ever. And also, as we go into the moon, you're going to have the integration of not only digital rendering, but also the photographic aspect. So there's going to be some merging of the digital content development and the photographic, which is very impactful. So what I see going into the moon is fantastic, and it's going to be never as complex as building in a space station. And believe me, we took 17 years to build that full space station in digital, in three dimensions, because it has so many components and so many parts, especially since we were using it for spacewalks. There were many cables and labels and things that needed to be done. So it took, you know, but if I look back, it took probably, let's say, about dozens of people, 10 or 12 people to build all that throughout all those years. Nowadays it's a lot easier, and it's gonna look a lot better. So as we go into the moon, like I say, the graphic engines are extremely more powerful, and the all the special effects added to that will be very easy to develop real time also. So it's just getting better. So simulating a gateway, which will be probably another ISS on the moon or the moon surface, all that is really, it's going to be less complicated. It's going to be a lot easier.
So now all the questions are flooding in, Evelyn. So I'll take the ones I have here. So we have 4 questions. Dawn would like me to ask her questions for her, so would Sudhir, and then Deborah has another question. So maybe what I'll do is I'll ask Dawn's questions, then Sudhir, and then we'll finish with Deborah's question, and she can ask it herself, since I know she has the microphone access when she needs it. So Dawn would like to know, well, first of all, let me jump. She makes a, and I have to say I don't understand what she's saying here, because she uses a, maybe you could spell out ESET for me, Dawn. But she said, my ESET will not allow access due to lack of door-to-door encryption. So I think that's a comment about how somehow it might be difficult to access these systems unless she's unless she's complaining to AT&T or something. But her other question was, can virtual reality help astronauts when they arrive on Mars and, you know, not being able to walk, having to adjust from micro G to 1/3 or 3/8 G?
Yeah, and that part is being, I have read some research about that they're testing using VR to help astronauts when they come back from the space station to acclimate to walking on Earth again. So definitely we can have a mitigation for that same scenario, stepping, you know, going into Mars once we get there. So, but I think first we need to get there. So, but yes, I think there'll be definitely, you know, a VR component that will be able to help astronauts when we get on Mars and on the moon for those purposes, yes.
And I presume that 4 to 6 month journey, VR could be really, really useful in training them for arrival, for tasks and catching up and doing, what do they call it? Not timely training, whatever it is they call it. But anyway.
Refresh training or
Okay.
on-the-go training. Yeah,
Right.
which is another thing that is happening actually. It's not VR related directly, but you know, now we can do all that very easily with digital technology.
Right. So 2 more questions. One is Sudhir. Sudhir Pai is asking, most of the case studies that you showed were single person. How can this be leveraged as teams? I think that may touch on the collaboration aspect. So most of the cases you showed were single person. How can you leverage this technology for teams?
As a collaborative, you mean?
Well, he's asking how you bring in groups of people, and I think you
Okay.
touched on that.
So the thing is that, of course, I couldn't get into that detail, but what's happening is that internally in your graphic space, in your environment, you can actually have basically what you do is you attach different helmets into that system, and each helmet becomes their own point. Then you attach that helmet node into to anything around or anybody or a node that flows into space. It becomes, so you can basically you can integrate as many people as you want to in that space. So I showed two because we have two astronauts in the space, but we can have 3, 4, 5. And then once you're all immersed in that environment, you're basically could be looking all at the same thing, or you can be looking away, but you look at each other, and you can basically get notes from what you're looking at or your perspective of something that doesn't exist. And that's that's when you need to think of that you're going to create an environment that you cannot replicate physically. Then you immerse the people in that. Now you are all seeing that to be configuration. And then you say, oh, maybe this doesn't work well here. Maybe you do this. And that's how you work in collaboration within that virtual environment. It's all digital.
Okay, thank you. And our last question goes to Deborah. Deborah, I'm going to unmute you, so please go ahead and ask Evelyn.
Okay, thank you. I was going to ask whether there are any plans to commission VR art for astronauts for long duration missions. The experience that was provided for us by Laurie Anderson at the Rice Media Center was spectacular. I still go back to it in my mind, and it is not something that you can have a real world version of.
And you're talking about art, right?
Yes, an artistic experience.
Yes.
Yeah, which is.
I have seen some incredible applications that allows to build incredible graphical with the basically a pointer, right? And you can create incredible art within this immersive environment. So, and that's very, it's great for your brain and development, you know, and your psyche. So I've seen incredible tools, applications that have been developed. So I cannot wait to see what else, what the future brings. And people are creating all these different applications with VR. And that's one that will definitely benefit, astronauts going into a long duration flight, obviously. I want to give you an example. One time I went to a conference, and I remember there was a company that had this, the conference was packed with people before, COVID-19, obviously. And it was, very noisy, a lot of people. And I was just getting tired because I'm trying to test all the helmets and AI and AR. And so I was getting tired towards the end of the day. And I saw this beautiful setup this company had with a VR experience. And they'll take you to like the jungle. And I sat there with the helmet, with the audio, and I literally kind of went away. Like for a minute, I think it lasted like 5 minutes. And I literally detached from the place. And that was kind of surprising because I wasn't expecting it. And just because I was always in the technical using VR, that when something artistic came to my visual in the noise and the sound, it was like beautiful. It really completely detached me. So I can see definitely that is a huge impact that I cannot wait to see what else is people going to do.
Yeah, and I think that also relates back to, the kind of mental health question that Leanne had asked and so on. Well, I think we're out of time and out of questions, and